Hey everyone, welcome back. Hope you're all doing well. In this video, we're going to learn about the collapsed as-built method for delay analysis. The collapsed as-built method, let's call it CAB for short, is sometimes referred to as the as-built but for method. It's a retrospective approach, where we start with the actual as-built schedule, then remove certain delay events to see how the project would have finished, but for those delays or changes. Here is the standard process for using this method, explained in more detail. The process begins with the as-built schedule, which documents how the project actually progressed, showing the real start and finish dates of all activities, as well as all delay events and changes like acceleration. This schedule reflects the true sequence of work and serves as the baseline for analysis. Once we have the as-built in hand, the next step is to identify which delay events were critical at the time they occurred. Not all delays impact the overall project duration, as they may consume float time available, so our focus here is on those that change the critical path. After identifying these critical delays, we create what's known as collapsed as-built, or CAB. This involves removing the critical delay events of a specific category from the as-built schedule. For example, if we're analyzing owner-caused delays, we would remove only those critical events attributed to the owner. This step effectively simulates a scenario where those delays never happened, allowing us to estimate when the project would have finished under different circumstances. The final step is to compare the completion date of this adjusted schedule, the CAB, with the actual completion date from the original as-built. The difference between these two dates reveals the time impact caused by the specific category of delays we removed, offering a clear and measurable way to assess responsibility for delays and their effect on the project timeline. Alright, now let's take a closer look at how this method is applied in resolving schedule delay claims in construction projects. We'll break down how it helps us distinguish between different types of delays and determine the responsibility of each party. Let's assume the project was completed and experienced delays. In such cases, the contractor wants to identify which delays are excusable and which are not for making claims. If a delay is non-excusable, meaning the contractor is responsible, then the owner may be entitled to assess liquidated damages. Conversely, if the delay is excusable, such as those caused by weather events or owner actions, then the contractor may be entitled to a time extension, or in some cases, even monetary compensation. To begin quantifying non-excusable delays, we develop what's called CAB-1, which is the as-built schedule with all contractor-caused critical delays removed. By subtracting the duration of CAB-1 from that of the original as-built schedule, we determine the total amount of non-excusable delay. This process basically isolates the contractor's direct impact on the overall timeline. The result is a collapsed schedule that shows how much time would have been saved if those specific contractor delays had not occurred. Therefore, the contractor must bear full responsibility for that time loss. This reduction is illustrated by the orange bar, representing a portion of the total delay shown by the red bar. For this calculation to be accurate, it is essential not to remove any contractor delay that did not affect the critical path at the time it occurred. Some delays may have happened when there was sufficient float in the schedule, meaning they had no impact on the overall completion date. These are considered non-critical delays and should not be removed. Removing them would result in an incorrect calculation of non-excusable delay. After identifying the non-excusable portion, we move on to determine the excusable portion of the delay, which serves as the basis for a time extension request. This is done by taking the total project delay, represented by the red bar, and subtracting the non-excusable delay, the orange segment we just identified. What remains is the potentially excusable delay, illustrated in green, which may be due to owner actions or neutral events like force majeure. Next, to identify how much of that excusable delay is actually compensable, we create CAB-2, which involves removing only the owner-caused critical delays from the as-built schedule. Again, do not remove any delay that didn't alter the critical path at the time it occurred. By subtracting the duration of CAB-2 from the original as-built, we find the compensable portion of the excusable delay, shown in purple, and subject to potential cost compensation. In summary, by carefully applying CAB schedules and comparing them to the as-built, we can clearly break down project delays into non-excusable, excusable, and compensable components, which are crucial for evaluating delay claims and assigning responsibility accordingly. Alright, let's go through this example together. This is the baseline schedule and it includes 6 activities labeled from A to F. Based on this plan, the project was originally scheduled to be completed in 52 days. This is the as-built schedule for the project. According to the final records, the project was completed in 57 days. Since it was originally planned to finish in 52 days, this results in a total delay of 5 days. Let's overlay the baseline schedule on this as built to see the difference. clearly, there were no changes to the first 3 activities, A, B, and C, while the remaining 3 activities were delayed. Several notable delay events occurred during the project. First, there were owner-caused delays. The owner delayed activity F by 2 days and later caused an additional 3-day delay to activity E. Next, we examine the contractor's actions. After the owner's 2-day delay to activity F, the contractor caused a further 5-day delay to that same activity. Interestingly, not all schedule changes were delays. The contractor accelerated activity D by 1 day, demonstrating that schedule changes can sometimes mitigate delays rather than extend the timeline. Lastly, on days 34 and 35, the project was impacted by adverse weather conditions, which affected activity D for a total of 2 days. Based on the dependencies, it was supposed to start right after the finish of F. Alright, the key question is, what caused this delay? If you take a closer look at the network, this is the critical path. Looks like it go through every delay event. However, we don't know how much each of them contributed to the final project delay. Now let's break it down using the collapsed as-built schedule, or KB method. First, we need to find out how many days are non-excusable. To do so, we're going to build a cab schedule without the contractor's events. It means we need to remove them from the as-built schedule to assess their impact. The resulting collapsed as-built tells us what the project could have finished, but for the contractor delays. It's important to note that we do not remove events that did not alter the critical path at the time they occurred. Let's first examine the 5-day contractor delay. This event began on day 23, following the 2-day owner delay. It occurred on the critical path because if it had not happened, the critical path would have shifted to a different one. This confirms that this contractor delay was indeed critical. Regarding the acceleration of activity D, it shortened the duration of the activity, which is part of the critical path. As such, it is also considered a critical event, so both of the contractor's delays are considered critical. We now remove these delays from the as-built schedule to create a C-A-B schedule without any contractor-caused delays. The resulting schedule includes only the owner and weather-related events. As shown, the collapsed schedule still completes in 57 days, identical to the original as-built duration, but without the contractor delays. This means that the contractor's delays did not cause any additional project delay. Therefore, there's no non-excusable delay attributable to the contractor. Why is that? Here is the reason. When you're removing the first 5-day contractor delay to activity F, it made activity F no longer a critical one. The critical path shifted to activity C. This allowed activity D to start 1 day before the weather event. However, the contractor had previously accelerated this activity by 1 day. As a result, removing the acceleration cancels out the change in start of the activity. Therefore, the contractor's delay actually had no net impact on the as-built schedule. Alright, since there are no non-excusable delays, the entire 5-day project delay is considered excusable. This entitles the contractor to a full 5-day time extension. Now, we must answer another question. Can the contractor claim any compensation for this excusable delay? To answer that, we need to develop another collapsed as-built schedule, this time by removing the owner delays from the original as-built. Let's return to the as-built schedule to assess the owner's impact. In this case, we have 2 owner-caused delays, a 2-day delay to activity F and a 3-day delay to activity E. Once again, we do not remove any non-critical delay events in the analysis. The first delay, affecting activity F, occurred before a 5-day contractor delay. At the time it happened, the 5-day contractor delay had not yet occurred. Activity F was not on the critical path. Actually, it had sufficient float when the 2-day owner delay occurred. Therefore, this delay event was non-critical and should not be removed from the as-built schedule when constructing the collapsed as-built. The second delay, however, affected activity E, which was the final activity in the network and on the critical path at the time. This delay directly impacted project completion and is therefore considered critical. As such, we remove this delay when developing the collapsed as-built schedule. And here's the result. As you can see, this KB schedule has a duration of 54 days, 3 days shorter than the original as-built schedule. This means the project could have been completed 3 days earlier if not for the owner's delay. Therefore, this time loss should be attributed to the owner and is considered compensable. As previously determined, the total excusable time extension is 5 days. After subtracting the 3 compensable days, we are left with 2 days of non-compensable extension. Alright, that wraps up this video where we explored the collapsed as-built method for delay analysis. Goodbye for now, and see you in the next video.